Welcome to our LinkedIn Live event, The Good, the Bad, and the Privacy Compliant, as a new format of our Mobey Forum Data Privacy in the Age of AI Expert Group. Together, we have right now a combination of people who are in the room here in Helsinki. We have representatives of different banks, Erste Group, Raiffeisen, Nordea. And we have also our speakers who are joining us virtually via Zoom. We have Alexandra Ebert from Mostly AI. We have Maurizio from Intel, Hartmut Schultze from Hewlett, Packard, and Dimitar Jetchev from Inpher. And we, before starting this interesting expert group event in the new format for Mobey Forum, I would like to let Ville, my co-host and co-chair of this group, to introduce himself.
Of course. So again, my name is Ville Sointu. I am the co-author or co-chair of this working group working on privacy enhancing technologies, especially the emerging kind that we've been talking about before. My day job is at Nordea. I work with emerging technologies in technology-driven business development. Part of my work, of course, is to identify interesting things like these privacy-enhancing technologies and see what it actually means for financial institutions like Nordea, whether they are a threat or an opportunity. I can certainly say that in case of this, it is definitely an opportunity to actually collaborate in a much more effective way. But Amir, maybe a few words about the expert group itself.
Yes, sure. So before, let me just introduce myself because I forgot to do it at the beginning. So I'm Amir Tabakovic. I'm an independent advisor in the area of privacy enhancing technologies and artificial intelligence. And I'm also an honorary member of Mobey Forum and the co-chair of this expert group. So we started this expert group some 1.5, 2 years ago, I think. By discovering that the privacy is one of the major challenges when it comes to introduction and deployment of predictive AI applications in banking. We started with the work, and in the meantime, we have different members joining from different banks and solutions providers within the Mobey Forum family. And this work resulted for now in the first report that we published in the June of this year. Yep. Maybe you can say something about our first report.
Yes, of course. So the first report that we, again, was a kind of long time writing, but it turned out pretty well. So we found a kind of good way to explain that we're really looking at a sweet spot between how to be compliant in terms of all the privacy regulation that is especially important for institutions like regulated institutions like banks, and yet to be able to leverage all the opportunities of data. Now, we especially in banks, we feel the pain that we perhaps are not able to be like Google or Facebook and use all the customer data in the same way as they are doing for obvious reasons. Again, there is regulation, there's supervision, but most importantly, there's the element of trust. If we cannot reach the trust elements that we have towards our customers. And this, of course, means that we also need to be trustworthy as custodians of important customer data points. So again, looking at these ways to make sure that we have the integrity of the data, the privacy of the data is maintained by using these technologies, it is a great opportunity for us to move forward in a data-driven innovation department as well. Now, before we go into this kind of new format that we're experimenting here, this is actually our second LinkedIn Live on this topic. We had some pretty hilarious technical problems in the last one on that. Let's see if we can manage through this one without any unintended mutes or wavings of hands like we did last time. But it was anyway a memorable moment for all of us. But before we go into that, a few words about Mobey Forum, or any of the audience who might not know about Mobey Forum before. Mobey Forum is a global not-for-profit industry association working in connecting banks and financial institutions and vendors working in this space to create better digital financial services for the society at large. And again, we have been together since 2000, so it's one of the oldest industry associations, especially focused on digital financial services. And we intend to stick around for another 20 years. So looking forward to all of that. So good. Amir, about today. So what are we going to do now?
Exactly. Like Mobey Forum is basically very good in exploring uncharted areas in financial services and the whole digital space. And I think with this new format that we are introducing today, with this open expert group, we are also exploring an uncharted area, not only when it comes to the format of our expert group, but also when it comes to the topic. I've been following what is basically happening in the privacy enhancing technology area for a while, and I have to admit that I never witnessed event with a combination of such an interesting speaker like we managed to get today to share with us their vision when it comes to privacy. And so that's why I would just briefly want to come back to the agenda. We will have 4 presentations of 4 excellent speakers, excellent experts in this area, followed by the panel. And after this panel, we will have also a representative of a bank. We'll have an interview with Maurizio Poletto from the Erste Group. And then that should basically, then we will be able to conclude this event in a little bit less than 3 hours.
That our common vision is that indeed these are all technologies that some people might think are competing, but actually they are not. So the optimal usage of this technology for me is really in a hybrid combination, as you will see. So hopefully that creates very interesting discussions with the other speakers who obviously develop and work on different complementary technologies. So today I'm going to talk about, I'm going to give you just very quick overview of Inpher, and then I'll switch to the technical basics. But before I do that, I'd like to talk about some financial services applications and regulatory support coming from these technologies. So Inpher was created in 2015, about 6 years ago, and includes multiple expertise in cryptography, machine learning systems, distributed computing, etc. So we have a large set of publications in the space. We're coming from background in mathematics, cryptography, machine learning, etc. And we are funded. We have been funded by various investors, including JP Morgan Chase, Crosslink Capital, Alpana Ventures, Alexa Fund, Amazon Alexa Fund, and most recently Swisscom. So some of these, as you see, are institutional, some of them are strategic investors. So the company is based in both, I forgot to say, US and Switzerland. Technical team is in Switzerland, business development solutions team is in the US. So to begin with, the problem that we are addressing is, as we call it, the 3 pillars of data security. So on one side, you have securing data in transit. On the other side, you have securing data at rest. And most interesting is securing data in use. So when your data is secured, the question is, how can you actually do useful computations on this data? And here comes the 2 major cryptographic technologies. So secure multiparty computation and fully homomorphic encryption, that presumably, and the long-term vision of providing this post-quantum cryptographic security as well. Of course, these technologies are complemented with multiple other technologies, as I will mention in my talk. So what the major idea here is that you use this type of computing with essentially enriching your data. So if you're an organization, a bank, or a financial institution, you may have limited data to just train or build or compute your model. So if you compute model with only your own data, the performance of this model may not be very satisfactory. So what you could think about is, can I enrich my data using other data sources that I a priori don't have access to due to privacy constraints? The simplest possible scenario is when you operate in multiple jurisdictions, and you use private data for, say, your customers, and in that case, you can't really aggregate that data in one place. So that's cross-jurisdictional constraint. You can talk about collaboration between different institutions in the ecosystem as well, in which case potentially you bring extra data that give you extra features in your model. So the question is that instead of bringing all this data in one central place, which is impossible or constrained due to privacy regulations, what you want to do is you want to compute without actually bringing the data outside of these institutions. So you do a distributed compute, but with strong mathematical security guarantees. So there are different approaches here, and they sort of, as I mentioned, they complement each other. So some people might think that they compete. I don't want to think that way. So in the first, in the lower left quadrant, you have anonymization. And we know that anonymization is often not sufficient because on its own, because you risk of re-identification. So on the lower right corner, you have secure enclaves, and we're going to talk about this more at this forum today. So secure enclaves, including trusted execution environment, so Intel SGX, AMD trusted execution environment, etc. So I will show you how this can be useful. So in a sense, that hardware security can complement what we are going to talk about today, which is secret computing. So differential privacy, on the other hand, is introducing noise in the data. And by doing that, you lose precision in the computations, but you could preserve the privacy of your original data. And in fact, here you have to be very careful of how much computation you can use on the data. So usually this is another technique that complements the other ones. And the one that I want to talk about today is secret computing. So secret computing relies on mathematically proven security proofs. And so the two major techniques that we will discuss are secure multi-party computation, fully homomorphic encryption. So Inpher as a company develops a commercial product called XOR, secret computing platform, that is based primarily on MPC, and it provides a open source library called TFHE for fully homomorphic encryption. So let's look at the applications now. So the first of the first and most common use case that we already saw was the situations or the scenario when multiple parties want to be able to share private data for analytics, say machine learning model training or inference, without a trusted third party. So if you have private data for party A and party B, you can't really bring it to a server, central server. So in that sense, like GDPR essentially prevents you from doing that. How do you solve this problem with secret computing? So here is the typical platform, and I'll describe it in detail. On the left, you're seeing the analyst portal. This is how a data analyst interacts with the platform. So with this analyst portal, what you have is you have an intuitive UI. You have a Python module that you could integrate in your Python data science code, and then you have also another REST API. The idea is that data scientists need not understand the internals of cryptography, yet they need to trust that what they use is secure. In the middle, Inpher hosts an XOR service. So this service sees no data, and so it only runs a compiler that compiles the program provided by the data analyst. And also it runs a random number generator. On the right, you have the so-called XOR machines. So these XOR machines are running on the different data sources. So they are deployed in different privacy zones. They can be deployed very easily. Obviously, this is the entire setting of the platform. So now what happens is the data analyst writes a function. Function gets compiled and distributed across the data sources. The data sources are computing. So this is the actual secret compute or multi-party computation, and secret shares for the results are returned back to the data analyst to reconstruct the result without seeing anything more but the result about the original data at data sources A, B, and C. So again, examples of the secret compute across sensitive data silos, cross-departmental or jurisdiction machine learning, insight monetizations, so enabling secure third-party analytics. Here you're seeing some of these cases, customer marketing models, where you build models across cross-organizationally. And this is typically used in a production scenario. We use this in credit and risk models. And then on the right, what you see is fraud and cyber threats. So this is important when you want to do fraud detection or even more generally anti-money laundering detection when you want to include multiple financial institutions. The use case that you will see is a public one that we did with Bank of New York Mellon. And it is about detecting fraudulent transactions. So before I move to the use case, just to tell you a word about GDPR compliance and regulations. So recently, on the right, you're seeing the recommendations of the European Data Protection Board on the use of secure multiparty computations for compliant data transfer and collaboration under GDPR. So that's an official document from about a year ago. On the left, there is an analysis of Baker McKinsey. So this is the use case I'm talking about, and I'll go very quickly over that use case. So it's a use case in financial services where you want to build a fraud detection model for transactions. So that's use case led by the Bank of New York Mellon. And the idea is that if you, what you see on these curves is that if you just use the BNY data only, you're getting this ROC curve. That's the purple one. And so secret computing is capable of improving that performance of the model by more than 20% by including data coming from a second bank and some government data, as you can see on these ROC curves here. So the outcome is that by doing secure data collaboration, you could actually improve significantly machine learning model that detects fraudulent transaction and thus reduce the false positives and also automate this process. That's the other advantage. So you're gaining in cost in actual manual processing of transactions. So that's the major use case. And what Inpher is doing is Inpher is providing a simplified version of this use case in our trial environment. So here you can see among that use case also multiple other use cases in finance. For example, you could see credit scoring use case. You could see a use case for predicting housing prices on the right using different data coming from government, coming from real estate agencies. You could consider a use case in joint intelligent collaboration. You have also use cases in healthcare. So that's a very different vertical. And on the right, you have yet another fintech use case on double-blind trade matching. So all of these are powered by secret computing, and one can actually play with them at this website. So now let me switch to the internals of what's being used in all of these technologies. So starting from secure multi-party computation, the main idea is secret sharing. So you have some data like the image that you see here. And what you could do is you could secret share that data across multiple parties. In the simplest case, these are two parties. So what happens is I'm giving each party a random image. So this image, you can deduce infer no information about the original image. Yet when these two parties collaboratively use the two images, they could reconstruct the original secret. But no party could individually gain even a single bit of information about the image. So that's the basic concept that is used in secure multi-party computation. Essentially, you secret share all of your data that all of your private data across a set of parties. So that way, no proper coalition of parties could deduce anything about this data. Now, how does this work in computations? So imagine that now I have to do a simple computation, like a multiplication. So what I do is my first number is secret shared across two parties, two or more. Here I'm showing just two. And my second number is secret shared across these two parties. So what happens is these secret shares are used by the two parties in a collaborative computation, distributed computation. However, during that computation, no information is revealed about them. And on the output of the operation, you get two secret shares as well. And these secret shares, they could reveal the result. So if at this point the parties collaborate, they could get the result, but they don't have to. They could just go and continue the computation. So that's the very basic description of secure multi-party computation. And there are cryptographic protocols that enable you to support these operations, which is what Inpher has developed. That's it on a very high level. So now I have to tell you about the other cryptographic technology called homomorphic encryption. So homomorphic encryption is very different than secure multi-party computation. So it's type of public key encryption where you encrypt some data. In this case, I've locked this box full of gold, and you can decrypt it with a key. So what is important here is that can you actually, while your box is locked, can you do an operation on the content that's inside? So that's the typical scheme that I want to show. So imagine that you have some gold inside. Can you actually produce a crown or a ring without opening the box? So that's really homomorphic encryption. And so more formally, what we do is we imagine that we have plain text data, these messages, and then we encrypt them. And then what we do is we imagine a box that is operating only on the ciphertext and producing a valid ciphertext of the result of the function that we want to compute. So if we support both basic arithmetic operations, then we are talking about fully homomorphic encryption. Otherwise, it can be either additive homomorphic, so only additive homomorphic encryption. Some applications require only additive, but for most of the generic computations that we want to do, we require fully. So some examples of how this is used. So imagine that I want to do a model prediction in the cloud. The cloud contains the model, but the data that I want to run the prediction on, it's a private data sitting on a client. So it's a local private data. What you could do in the case of FHE is you encrypt the data locally with this homomorphic encryption scheme. So you put it in the box and then you lock the box. Then you send the box to the cloud. And the cloud doesn't want to give you the model. It's going to run the prediction on the model and then return the encrypted prediction, which you then decrypt with your secret key locally on the device. So this guarantees that the client data is protected. So no plain text data is sent in the cloud. What you run on the device is basically only the encryption function. The actual model evaluation, the heavy lifting here, is done on the cloud. And then back on the device, you run the decryption. So if you want to make this like sufficiently complex with complex machine learning models, then you probably need some hardware accelerations, as we at Inpher do. So the other scenario is a bit different. So you have a proprietary model that you may want to evaluate locally on the device. That's also a possible scenario. Here we've given an example running on the Amazon cloud, AWS. So what you do is you have your data locally. You don't send it to the cloud, but essentially the cloud asks for a prediction. So it encrypts the model. It wants to preserve the proprietary model, and then sends the encrypted model, which then gets applied to the data locally, and you get the prediction, which the cloud then decrypts with its secret key. So this is an orthogonal scenario of homomorphic encryption. Of course, these are very typical scenarios that you could talk about. These are not the only ones, I should mention. So now getting a bit more technical, obviously, in homomorphic encryption scenarios, you may need to do different types of computations. You may want to compute with numbers. You may want to compute with real numbers or fixed point computations, as in physics and other sciences, or you may want to also evaluate binary circuits. So this is all that I wanted to say about homomorphic encryption. And now in my last slide, I'm going to talk about a hybrid combination of all these technologies, which could potentially also include other technologies such as trusted execution environments. So this is the type of technology that you commonly see as a federated machine learning with secure aggregation. So the goal here is that you have multiple devices. You can think about thousands of devices or even millions of devices, typically with limited computational capabilities. And what you want to do is you have data on each one of these devices, but you can't really send it to a central server for aggregation. So what you do is you do minimal computations with this limited data on each of these devices, and you get some local models that are not at all exact, so not at all accurate. They can't solve your real problem. But when you send all of them to a central server, aggregation server, then the server can actually aggregate these models and get a meaningful global model. And then you iterate this process, just as you do in any meaningful machine learning training algorithm. So what happens with that is at the end of the computation, the analyst gets a high quality model. Now, federated learning is very popular in many areas of machine learning these days. What is less obvious is how do I protect my local data from the aggregating server? If you just send the local model updates to the server is going to learn. In many cases, it can learn even all of your local data. So you don't want that. These are called model inversion attacks. So what you do in this case, you use secret computing, MPC and FHE, to actually protect these models from the server. So the local models, the local model updates are protected from the server. Additionally, if you're the data analyst, you may ask a question of how can I protect my global model from being poisoned by some of the clients? Imagine that you have a malicious client that is trying to poison a model, so bias the model or make it, put some intentionally some biased data. So this is where the other technologies, like combinations of FHE and trusted execution environment, can solve your problem. So in a sense, that's a typical example of how hybrid computation could occur. And orchestrating this hybrid computation is a non-trivial task in privacy-enhancing technology. Inpher as a company, for example, is building non-trivial development tools that allow you to orchestrate this whole computation, yet make it very intuitive to the data analyst. I'm going to stop here and ask for questions.
I think we got a really great first presentation. People here are cheering us. It was a real nice overview. And first, before coming up with the questions from this round, Mia, are there any questions from LinkedIn Live? No.
I have a question.
Yes.
Hi, nice presentation. My question is, in the first slide, you mentioned that AWS is having some integration capability from your services or from that technology you're describing today. Can you elaborate more? What can I find in AWS of what you talk about?
All I said here was that, so our product is on the AWS marketplace. So all I said here was that essentially we could deploy our product on AWS, on the AWS environment. So we could use standard AWS services to power our orchestration. That's all that I said. Of course, Inpher is, you would see in the press that Inpher is funded by Amazon Alexa Fund. So here what I'm saying is very generic. So what I'm saying is that you could deploy Inpher's, you could use the AWS services to power Inpher's privacy enhancing capabilities.
Thank you.
If I may first of all say that this was a very impressive presentation, what you have done, and also the way that you describe it to a less technical person like myself, that I can catch up with the bits and pieces of it and see the potential. Here in Finland, we are just in the process of updating the legislation for against money laundering, and it's obviously, as we know, the way it has been done in the past has been outrageously expensive and silly and inefficient and so forth. And what you are really showing here is a kind of a key to make it both efficient and above all cost efficient. So the banks in the world should grab this right away. Thank you.
Thank you. Thank you. So just a comment on money laundering. Inpher presented a money laundering use case 2 years ago, a big money laundering use case in one of the biggest conferences in applied cryptography, real world cryptography in New York. So there is a whole presentation on that.
Okay. So final question from Hewlett, from Navia.
Yeah, so we have a lot of banks, of course, in the audience, myself included. Now, one of the things we realized when we started working with these emerging privacy-enhancing technologies, that sometimes they are quite difficult to explain, especially articulating how to get started. So a simple question: if you would talk to a banking audience right today, and the banks would like to get started on something like anti-money laundering based on these principles, how would you kind of tell them to get started?
So the very first step is go and subscribe on trial. So that's why we put trial. I should say that from a business perspective, trial is an excellent educational tool for banks, and you can even try how this works. So for obviously, you're absolutely right. So the education takes most of the time and effort, and this is very important. So people should understand what the security implications are. But the first thing to begin with is just getting your hands dirty with this technology is very important, and that's why we built trial. It's free and people can use it.
Yeah, thank you very much. I think we should also, there is one question from Alexandra Ebert from Mostly AI. So
thank you, Amir. So Dimitar, thanks a lot. I can only second what was already said. Super great introduction to this topic. And I really like this analogy of creating a necklace without opening the box. One question in regards to state-of-the-art performance of fully homomorphic encryption. Last time I looked into the topic, it was said that oftentimes computation takes 1,000 to 1 million times longer than when computation is done on clear text. What state-of-the-art when it comes to performance and speed?
So thanks, Alexandra. That's an excellent question that I should have commented on earlier in my presentation. So fully homomorphic, that's exactly the point where we need to think about these hybrid approaches. So basically, fully homomorphic encryption on its own is not going to scale to the point where to the complexity of the models as well as the complexity of the data that you put into training these models. So fully homomorphic encryption, so nowadays there are lots of improvements, hardware accelerators, hardware acceleration efforts. We at Inpher, we do a lot of that work. But what we've identified really is that for each application, there is a trade-off between the scalability and the technology that you use. So for instance, secure multi-party computation these days scales much more than fully homomorphic encryption. Yet secure multi-party computation cannot solve all of the problems that FHE can solve. So even further, for cases where secure multi-party computation cannot scale, that's why we use this federated learning. And that's the excellent example of how you put together all these technologies in a hybrid solution. So yes, your question is very important, and according to the size of the data and the complexity, for example, if you're building a neural net model, then you have to think about really how you put a hybrid approach. This is achieved also by like very sophisticated developer tools that need to be built.
Thank you very much.
Dimitar.
Okay.
Yes, I would like to talk about decentralized and confidential clinical machine learning, and now I have another field. So as Dimitar was talking about, not only banking has the problem of privacy and confidentiality, also medicine does have it. And I have a use case in medicine, but I'm pretty sure that you will immediately and very fastly also connect to this as well, as this is pretty much the same topic what we're trying to reach here. So let me go through this real. I start. So what do doctors do? Now we got an escape into another field and into another domain. Doctors read patterns from data when making diagnosis. Medical histories, which are privacy information, so PII data, physical examination X-rays. If there's no metadata added, it's anonymous data as well already, or histological diagrams, computer tomography, pathology, MRIs, which is computer vision, which is NLP of patient records. So it's patterns within data. And basically that's the same thing we have in banking as well. So there's another notion though. If we go into the future, we're seeing that we're especially going into extremely large data sets. For example, if we're talking about the highest resolutions of MRI data in computer vision, then we're talking easily in the terabyte space, where we have one single picture, which is then to be analyzed in conjunction with a lot of other pictures or scans what we actually do there. Same thing happens with omics data. So omics data as the raw data, very private raw data, which has to be analyzed. It's highly informative, but it's not easily to be seen. So for example, a human sense, or we as humans, we cannot sense this. So we definitely need artificial intelligence on heavily private data and to create those data spaces to get patterns out of that. To actually make this usable, we've seen some different studies. So for example, what you see on the left side, there was a study in 2019 where a professor at MIT took together 90,000 mammograms, and they detected in the model actually patterns which were too subtle for the human eye to actually detect. And that was exactly like Dimitar. I like this picture you just shown about if you only have one, and then you go across, and then you have a large data space, then you get a better area under the curve, which is potentially going to the accuracy towards one. So the more data we have in access, the better we actually can get. The other thing is, which then might work in a scientific setting when you get all this data together to make this happen. If you don't have access to such data, each model is going to be pretty much useless. And that's exactly the curve which was shown there. So what we actually need to get out the real information out of that, we need to have the right access to the right data. And of course, it needs to be privacy preserved. There's another topic here which is extremely important, is bias in the data. We as humans, we have a bias. Nevertheless, each doctor has a bias because his experience is within what he is actually doing. So if we would like to go into a data-driven perspective to get this more in depth, of course, then we need to have this access to this data silos, which are definitely across entities. So it's not under control of a single party. So when we're looking at a data pipeline in the hospital, you pretty much have a patient, then you have different diagnosis instruments like microscopy, MRIs, blood tests, genomics. You generate data, which is private, as said. You apply algorithms to it, and then you have this within, for example, one hospital, one clinical hospital, or within a consortia, which brings this together, what we see in different countries, for example, also in Switzerland with the SPHN. So now depicted here is a hospital, but it could be, of course, the same thing with a bank, right? And that was the intra of the intra versus the inter. So if we look at that, it's only a limited data set. It's the model a certain hospital has or can actually work on, and they cannot learn with others. So that's if we do that on a single space. So putting this data together, that's the centralized model where we then potentially apply homomorphic encryption to the source data, which is large. We just heard that scaling this is not necessarily the way to go. Then we could put it together in a secure way on secure multi-party environment. But then we have the topic of the governance, which is on top of that. And of course, there's GDPR, and in health space, we have HIPAA or the CCPA, and we need to have the data sharing agreement. So the willingness to share is also a topic which needs to be solved across the data privacy. Now, you heard me saying about the large data set. There's another notion, might not be as much applicable to banking data because that data is per nature not as large as it would be in the medical field. But there's a notion of data movement. As soon as I start to move data, I, of course, need a lot of energy. So, for example, if you just look at the computational space and everything what we would like to do in AI, a lot of energy is actually used, not as much as we need it currently in the crypto area, but nevertheless, about 1/3 is only to do with data movement. So the more data we are going to have, we should prevent data movement and also, of course, data duplication, because as soon as I duplicate data from any kind of whatever enclave, it is then in the wild. So as soon as I have a duplicate data, which is then decrypted, of course, I cannot control it anymore. So being really sovereign on your own data, you need to take care about duplication. And as such, data sharing and open data should not be done, at least not in the medical field. And I was just in a conference and we had the notion of, or the title was Share Without Sharing. So what can we actually do to make this happen, to actually get or share the insights, get the insights of a consortia of working together, collaboratively working together without sharing the raw private data. So how can we actually approach this? So same procedure in the medical field. So we start this, but now we do it differently. We bring the algorithm to the data. So send the model, send the agent to the data instead of vice versa. And that reduces the following thing. So looking at that, hospitals can work together. That is exactly the federated approach to that. And so we share only the insights, we share the results, we do not move data, we do not duplicate the data, keep their sovereignty, but at the same point in time, enlarge the data set. So that is a decentralized learning. Here in the medical field, we can then come from a classical field of medicine into the systems medicine. So AI is necessary. We need to have access to a lot of data. We need this collaborative approach and make clinical data also usable. Now, there's one additional things where we say we have to do on a governance perspective, the right abstractions layers so that we can apply the models, which are then from one party, and have the data maybe is from another party, to do the automated decentralization and keep the data private in such a swarm. That's why we call it swarm learning. So now looking at the different frameworks and the journey we're currently seeing, that is something, local learning, of course, separate, as said before. Then typical notion of how we approached AI in the beginning was centralized learning. So we put all the data together. We did move the data, have the parameters together, do the results. And now, of course, if I have that, then I might apply directly homomorphic encryption. So I have the data safe, but still the data comes together. And then we have the federated learning approach, like Dimitar was just mentioning in his last slide. And the typical notion, and that was also, and that this is about the almost overall situation, that we do the computation at the edge, at the data source, so that the raw data is not leaving that. Nevertheless, from a consolidation of the parameters, this has still been done centrally. And now I ask you one question. If we have a certain situation where, let's say, 10 banks work together, who is going to be the bank who is leading the central server? And there I'd say we will not be having it. Because there's no primus under pares, so we're not seeing this one bank who has then the power to actually do that, and that's why we say Swarm as a function now decentralizes that as well. So the consolidation of the parameters and the data is going to be at the edge, and that implies then also that we have a privacy enabling, leaving raw data at its source, a collaborative machine learning, and then training all parties equally in sharing the results and based on a common agreement on how to actually do this. So how does it work? Well, let's see, or did it work? So we just published this year a paper in Nature where we applied this technology to a setting of 16,000 data sets in different diseases. So we wanted to make sure that that this technology actually works. Also, we applied it to X-rays, 95,000 X-rays, which are publicly available, and then we split up this data set and see, is it the same thing what we get from a centralized model or from a decentralized model? What we actually could see, and that is what you see here, it's mimicked that we split out in different permutations, a lot of permutations on different nodes. So each of these nodes had a subset of the data. And I must say one very important thing is we knew exactly what the result was going to be. So we knew exactly what the accuracy was because it took about 3 years of data curation before, and with classical linear regressions and classical models, that we knew what we would like to see or what the result should be. And there we applied this swarm so that we could actually see and prove that learning together in a way to spread out all the information is equally as good as a central model or better. So what you see on the left side here is a training phase. You have 32 nodes in this way. You have 50 or different prevalences on the different nodes. So they have different information about that. We applied this to a global testing set. So typically what you would be doing in an inference phase as well during your then applying of the model. And what you see on the right side is the different nodes, different permutations on that. And what we see throughout our 50,000 runs we did is that Swarm was always better or on par even with a centralized model. So it doesn't matter if you push all the data together or you leave it where it is. So there's one thing to this notion that you have now the choice, just splitting this. Well, to be known, if you don't move data, which is private, and you leave it with the data controller at the source, the raw data at the source of where you actually have, you can still get the insights based on the model you're trying to reach with in a collaboration with the partners. So there's another notion here. So what we tested then as well, and what you see is the epochs on the bottom and the accuracy on the vertical line. And what we did, we took some dynamic addition of different nodes. So for example, we had a prevalence, so a bad training node, which had a bad or a low prevalence between the nodes. And we, of course, as expected, generated a lower accuracy. So we took the same thing with different nodes who were better in training, so they could converge to the better accuracy throughout these epochs. And the epochs is always a certain time frame where the nodes by itself train on their own. So they have their data set where they train locally, and then we combined this. So if we put this together, so low prevalence nodes and high prevalence nodes, we then saw we could, throughout the training phase, add additional nodes and still learn as the swarm together in a much better fashion and reach the right accuracy we were striving for. So that means that you can dynamically add additional nodes throughout the learning phase to actually create better predictors on what the different patterns on the underlying data structures is. The same thing works as well if, for example, in such a network, you lose certain nodes throughout the training. So even if you have a failure in the communication between those nodes throughout the training, actually it picks up from the other nodes the results which are then on the overall scheme. Now I come to a point which pretty much reflects also what Dimitar was already mentioning. It's the combination of different notions. So we have also here the data at rest, data in transit, and data in use. So it's a combination from blockchain technology, or it's a distributed ledger technology, what we deploy here, which is then doing the immutability of the results on this transaction log. This has one notion that in this blockchain, you register everything and everybody can then look into that. So we have the transparency of the contribution of all the parties. So if there is a malicious party who is acting malicious in this respect, then we can identify this. And this is one base for this very much and very important notion of how do we actually enable trust, because trust cannot be generated, it is only earned. And all the parties must work together if they want to work together and trust each other. So from a pipeline perspective, as I said before, we move the de-identification to the data owner. We learn on a read-only data point where the data is not going to be then moved out of the ownership and the controllership of the data owner on the left side. A differential privacy, this noise we were just talking about, can be applied locally. We have also a trusted execution environment, which is locally. And then only through the attestation of access to such a specific node, as you see here, it's 1, 2, 3, and 4. This network of nodes have then also a homomorphic encryption of the weights within the distributed ledger. We explicitly don't use a public ledger, but explicitly use a private permissioned ledger because we say, or we must actually make sure that we are not or are sustainable here as well, because as you know, public ledgers from a consensus perspective is much suboptimal, and as we need to have a consortia between those parties working together, which is basically, again, a swarm working together on a common goal, we have this notion of this collaboration based on contracts and persisted on a trusted ledger. So there's another topic, of course, which is the model by itself, which needs to be trusted. So not only the data which is fed into such a model needs to be trusted, but the model needs to be trusted as well by the parties, that this cannot be inversively attacking the data and exploiting the data. So there must be a certain governance around it, which then also includes the ownership and regulations around it for the model by itself. So this is this notion of consortial data governance and model governance, which is then above. So the combination of those is what brings this. We have this also in our paper based on nature. Interestingly enough, there were different groups now looking into that, and on histological data, they could see exactly the same results. So a central model has no improvement over a federated or swarm learning model as it is here. And the abstraction is then really on the model, which is using standard machine learning libraries like TensorFlow or PyTorch or Keras. So what does it mean? Moving data, leaving raw data at the edge where the data is generated, have a like-minded partner network, and leave the data protection and the data security at the source. Getting larger data sets and less susceptible to bias in machine learning, while having a higher resiliency, moving out training partners or getting in training partners. We also have this as a trial version, as an open version, so that everybody can apply it. It's also containerized on a zero trust elements, so that we do attestations all over the place when getting these parties together. We as HP, we don't deliver the model as such, because we believe that the model must be a domain knowledge or the parties actually working together. And also the data owners must not be in anyhow influenced by us. So we're building this orchestration we were just talking about underneath, where we can make this happen so that party can collaboratively work together. I have one slide on just how to show you how it actually works. So basically, you have a registration in a swarm from the models. You do a training. All the nodes do the training, they get their weights, and then the aggregation of the weights throughout a single epoch is done at a certain node. So even if this node fails in the next phase, this training is repeated, but another node is being elected to collect the information. So there's no central server, no central party of actually aggregating this throughout the training. And with that, I would like to go for any questions you have.
Thank you, Mr. So,
Many questions on the net.
Yes. So shall we? We are now. Thank you very much, Hartmut, for the presentation. And we have one question from Bo.
Thank you, Bo Harald here. I'm on the steering committee for My Data, and obviously there we are pushing forward with putting the person in the human in the middle of the process, as GDPR in Europe is also doing. And there we have seen that trust over IP and SSI has been the way to actually make data travel in a safe way. So my question: how much is this supporting self-sovereign identity, and how much are you participating in that work in trust over IP? Thank you.
Yeah, well, several self-sovereign identities, you're mentioning the Gaia X notion, that is one base to that, since the attestation of the collaborative parties should always work on the identities of such SSIs. So the attestation and the policy around who contributes to such a network is then a consumption of such a identity.
Alexandra Ebert. I am Chief Trust Officer at the synthetic data company, Mostly AI. And today I will talk about AI-generated synthetic data and how it helps particularly with building the AI bank of the future. Why AI bank of the future? Sorry, my slides don't move as intended. Now they do. McKinsey and basically any other consulting firm, professional services firm is telling you there won't be a future for banking without AI. For example, from a recent report from this year, they said AI is no longer a choice, but it's a strategic imperative to really ensure adoption of AI technologies across the enterprise. Some of the reasons listed in this report are the increasing competitiveness in the landscape with big tech players entering, with innovative startups, and then of course also changing customer expectations. One of the most important ones is that personalization really is key, and that customers nowadays expect highly personalized services, so that you really switch from product centricity to customer centricity, and also taking the context of your customers into account. So customers don't want, of course, the email that notifies them about a fancy new service offering, but they really want to be offered and exposed to this offering right at the relevant point in time when they really could need this service. So this really means that as an organization, you have to become in a position where you granularly understand the behavior of your customers, which of course requires access to data, and not only their behavior, but also their context. And this then of course can lead to different intelligence propositions, but also collaboration with partner ecosystems, which is one of the other key pillars that's kind of in the future outlined by McKinsey. But also speed will become crucially important, because not only is it about speed and agility and being in a position where you can launch new features in days or weeks as opposed to months, you should also be in a position where you can collaborate extensively with existing partners, which again requires nowadays that you can share data. Yet, compliance and trust are still essential for financial institutions. We've already heard this. Banking is a business of trust. And despite all the speed that's required, of course, financial institutions can't afford not to comply with all the regulations that they have to comply with, or to risk the trust that the customers have put in them for the last centuries. So for banks, it's definitely a quite challenging environment nowadays. And especially when we talk about regulations, we can see that regulatory complexity is increasing. I'm sure everybody's familiar with GDPR on the upper left. Please excuse Russia and Britain here in my map of the EU. I was a little bit in a hurry when preparing the slides, but in general, the majority of circles you can see here are drafts of upcoming regulations, which really show that working with data will become even more complex than it already is. And what's the consequence of this? The consequence of this is that, as Ami already pointed out in the introduction, privacy can be one of the major roadblocks for you to innovate with data and to build new services and product offerings. Gartner predicts that already in 2 years, 65% of the data of the world's population will be covered by modern privacy regulations. And it's not only GDPR, it's really also CCPA. China just recently introduced a privacy regulation. So it's getting more and more complex, not only in the EU, but also on a global perspective. What are the concrete challenges that we have due to these regulations? The first one is definitely data access. What we hear from our clients is that most often it takes them many weeks, sometimes even months, until they can access data for internal projects. And as soon as they want to share data, it takes even longer. Then, of course, utilization is an issue for them, because in the past, especially when it came to data sharing, they used legacy anonymization techniques like masking or obfuscating, which I will come to that in more detail in a few seconds, really limit the utility of a data set, especially when it comes to AI training and advanced analytics. And then also there are many data governance issues, the risk of unauthorized access, the risk of data breaches, and also complicated regulatory requirements to manage, like the right to be forgotten, data retention, and so on and so forth. And I already briefly talked about it, legacy anonymization. Legacy anonymization was one of the way outs for all this regulatory complexity, because, as we all know, anonymous data is exempt from the GDPR and other privacy regulations. The problems with legacy anonymizations, though we already heard it in one of the earlier talks, is that it really doesn't work anymore for large data sets. So there's a huge body of research out there that highlights that with these legacy anonymization techniques like masking or obfuscating, it's impossible to prevent the data to be re-identified. And therefore, we've seen on the one hand a few nice headlines on these papers, but also from a few companies that thought, okay, what they shared was anonymous, to then find out it in fact wasn't, and having to deal with privacy fines, regulatory and reputational damage. So this is definitely a problem when it comes to legacy anonymization. To give you an example, one study, for example, showed that 80% of credit card owners could be re-identified by only 3 transactions. And if you think about the amount of transactions that each customer takes over the course of a year, 3 transactions in the first place is not a lot of utility that you can preserve. And it wasn't even the full transaction and all data points from these transactions. It was only the information about the merchant and the date of the transaction. And these tiny pieces of information were sufficient to identify over 80% of customers, which really shows legacy anonymization does not only help to protect privacy, or does not help to protect privacy, it also destroys all the utility in your data set. And a quite nice graphic to illustrate it here with different techniques is that you can see the privacy and utility trade-off. On the left side, we have 100% useful data. Everybody will know that this is Will Smith, but of course it's not private, it's not protecting his identity. On the very right end, we see 100% private data, super GDPR compliant, free to share, sadly not useful. And anything in between maybe makes the data, or definitely makes the data less useful, but as the studies showed, doesn't protect the privacy. So only if you're somewhere here, you can say, okay, I protected the privacy, but you can't do anything with this legacy anonymization anymore. And to illustrate this maybe in a plot, we can see that we have this growing gap for innovation, because we have more and more data nowadays compared to maybe the last 10, 20 or whatever years ago. But with legacy anonymization techniques, there's always this hard cap, this ceiling that you can't retain more than just a tiny piece or a very few data points before you run into the risk of re-identification. And this is the introduction, how synthetic data can help you overcoming this regulatory complexity and being able to innovate in a way that's privacy preserving and GDPR compliant. Synthetic data, on the one hand, is data that's nearly as good as the real data, but it's still fully anonymous. So you get much, much closer to your original data, yet you protect the privacy of your customers. It's quite easy to understand if you look into pictures. The pictures you see here on the left are from an NVIDIA research project. And what they did back then was they trained an algorithm on hundreds of thousands of human pictures, up until the point where the algorithm understood how a human face looked like, that humans have, I don't know, 2 eyes, 1 nose, 1 mouth. The eyes are roughly located in the middle of the head. It really understood how a face is constructed. And once this training was completed, you could generate new synthetic photos of humans from scratch. And these are the results that you can see here. So I would say everybody would agree that these are highly realistic photos and everybody would expect them to be real photos. But in fact, the people here have never existed before. They're synthetic faces. And the approach to anonymization when it comes to synthetic data is so sophisticated that you're not just shuffling around some parts of the data. So it's not that, for example, the algorithm saw one training image with this type of nose and took then the eyes from another training image and the mouse from another image and just shuffled this together. But it's really just learning the logics, the statistics, the rules behind human faces in that example, and then use this information to construct completely new data points, completely new images from scratch that don't have any one-to-one relation to real humans. And this is what we at Mostly AI do, but not for unstructured data like images or videos, but really for structured business data. So think of your customer database as your financial transactions. How does this process work? We provide our software to our clients. So we as a company never get access to any sensitive customer data. And they use it internally to synthesize their data assets by selecting the data that they want to synthesize. And then automatically a deep learning algorithm learns all the patterns, all the structures, all the correlations, all the time dependencies in the data. To say it simple, it understands how your customers think, act, and behave. And up until this point, when the training is completed, or once this training is completed, you can generate an unlimited number of new synthetic customers that have all the same statistical distributions, correlations, time dependencies, behaviors, just as your original customers have. But the benefit is that they're created completely from scratch and that you don't have any real customer data in there. So you're out of scope from GDPR, but still retain the utility of your data set. To give you a few examples with some of our financial clients, we saw, for example, that still all the ratios of how the customer bases looked like were retained, but really to a very granular level. So even behaviors like, I don't know, the old granny going to the cash machine just once per month, but always retrieving the maximum amount of cash was preserved, as well as, for example, that different age groups have a significantly different spending behavior and financial behavior. So what concretely are the benefits of using synthetic data as opposed to legacy anonymization? On the one hand, you're significantly faster and can get to data much, much faster. I can come to this, we'll come to this later also with the use cases. But up until now, legacy anonymization was always a case-by-case basis. So what we heard from many of our clients was that these data access requests really took months, where there was negotiation between the different parties, privacy department, DPOs, and so on and so forth, whether they really need all the data that they requested or could maybe make do also with little data and less data that they actually requested. And once they finally got the approval, the data was legacy anonymized on a manual or on a case-by-case basis manually, which again added a few hours, weeks, or sometimes even longer to the already very stretched time budget. So oftentimes it was really 3 months, 6 months, or sometimes even 8 months until a department received the data that they needed. With synthetic data, the whole process works automatically. So you don't have to change something for specific data assets. You just select the data, push it through the system, and can get to your data in a matter of hours or days. So significantly faster, which comes back to the speed that was highlighted in the McKinsey report and how important it is going to be forward. Then, of course, you eliminate privacy risks. Since synthetic data is artificial data that's generated from scratch and not original data where you just shuffle or mask or obfuscate some existing points, there is no way to come from the synthetic data back to any real data points of your customers. So you don't have privacy risks of re-identification. Then you can retain much more accuracy. We saw it already on the graphic. Usually what we hear from our clients is that we retain approximately 97, 98, 99% of accuracy, and that even machine learning models that train on synthetic data perform as good, sometimes better, sometimes nearly as good as models trained on original data. One very important aspect of synthetic data is that it's super easy to collaborate on this data. It's not only possible to freely give people access within your company, but also to share data across borders, to collaborate with fintechs or with other partner companies. Then you also save lots of costs because much less human involvement in the whole process. And since it gives you access to granular data, it's the basis to improve your customer understanding. Especially coming back to the accuracy, I just brought a few slides. Here you can see that distributions at customer level are preserved. And here you can't even see the gray line, which is the original data. You really have highly accurate data that's super granular, both on a global and general level, but also when you zoom into different synthetic individuals. And as I already mentioned, you can use synthetic data to do machine learning on top, and you can immediately then deploy the models that you've developed on your production data, because synthetic data has the exact same structure than your original data. So for all those scenarios where you'd love to have training data available for your machine learning, but can't access it due to privacy reason, synthetic data is your way to go, because it's out of scope from GDPR and can be freely used for AI training. When it comes to the privacy, synthetic data is more and more considered and recommended by European regulatory bodies as one of the ways to go moving forward. For example, just in, I think, June this year, the Norwegian Data Protection Authority issued a fine to an organization that used production data for testing and explicitly mentioned that they could have used synthetic data as an alternative. But there are also many more statements about synthetic data. And then, of course, we as a company not only have our internal privacy experts who make sure that synthetic data can't be re-identified, we also work with global leaders, especially on the technical side, but also on the legal side, to really make sure that synthetic data is as good and as private as GDPR requires it to be. And also our customers, when they do their independent analysis of the technology, like for example, you can see here Erste Group, they come to the conclusion that synthetic data is their way out from many of the analytical challenges that they have when it comes to privacy. So for example, here we had Erste Group saying that they see synthetic data as the foundation of all future data-driven developments, as it provides the only GDPR compliant method for unlocking advanced analytics and insights based on your customer data. So now the use cases that I promised. What can you do with synthetic data? I would say the top use cases for synthetic data, which we see with our clients, are on the one hand, AI training and analytics. This is really one of the main application areas of synthetic data nowadays, specifically to the problems I described earlier, that you need vast amounts of data for AI training, but oftentimes can't access this data due to privacy constraints. Testing is another very promising field, and we just had our new release where we specifically introduced some capabilities that will synthetic data even more useful for testing, because with testing you need highly realistic, ideally production data to test all different scenarios and edge cases, and production data of course is something that's not allowed to be used in low environments. So also here synthetic data can work as a drop-in replacement. Then it's for digital product development, and also very interestingly for data sharing, being this cross-border data sharing with different subsidiaries of a bigger group, being this to validate vendors to move into the cloud or to collaborate with startups. I specifically also mentioned cloud migration again, because this was one of the earliest use cases that, for example, a large insurance company, which is a client of ours, used synthetic data for. And then it's also for data retention, because there are many obligations that require you to delete data at a certain point in time. But with synthetic data, you can, in an anonymous form, retain all these insights over a long period of time, which helps to boost the accuracy of your models and also helps in areas of fairness and mitigating biases. AI governance and algorithmic auditing is a more new topic, which is becoming more important now with the proposed AI Act in the European Union. And then we also have open data initiatives. So for example, the city of Vienna set out to share synthetic data sets with researchers, startups, small and medium enterprises in an effort to democratize the asset to data and make it readily available so that also the small players in the field and not only the big tech companies with vast amounts of data can innovate. And I have a more concrete use case here for you as well, which is of one of our clients who analyzed 1 million e-commerce payment transactions of the client in Brazil, and they wanted to use them for advanced analytics and also for testing purposes. And as you can see here, that many details of the data set were perfectly retained on a more general statistical distribution level. So for example, how long the delivery periods were from one area of the country to another area of the country, which suggests that the warehouse is somewhere based in Sao Paulo, below here. But it's not only the global statistics, it's really the granularity, which is so important to understand customer behavior and make personalization happen. So what they really saw is that the data reproduced complex online payment journeys where everything was retained from, for example, what type of payment method was chosen, which items were purchased, how long different periods take, where some issues in their warehouse and delivery chain were, and so on and so forth. And one thing that's also very important, especially when it comes to testing, is that our platform is capable of retaining implicit business rules across schema, which really also when you synthesize whole databases is important to have feasible data for your testing efforts. But this was just one example. Another example, I don't have any slides on this, but is coming back to this data sharing use case. A Fortune 100 bank has the need to, for example, validate over 1,000 vendors and also startups every year, which up until now led to significant costs and also time commitment from the whole team working on these initiatives. And with synthetic data, they were able to reduce the time it needed them to, or it took them to share data by 70%. And the costs associated with it by 80%, which at the scale of this company with 1,000 vendors and startups that they validate each year resulted in 10 million of cost savings annually. So just a few examples of synthetic data usage, but basically it's a technology that unlocks the data and makes it free to share, use, or analyze for whichever use case you want to use it. So I think I'm out of time, therefore jumping to this slide and happy to take any questions about synthetic data.
Thank you very much, Alexandra. Great presentation.
Thank you.
I learned that legacy anonymization techniques are dead, long-lived synthesization. So very, very interesting potential, and also I think many of our attendees, they know very well the pain of long data provisioning cycles of multiple months. So this could be an interesting solution. Do we have any questions from the audience?
I see that Dimitar has a question, but maybe if we have something from...
It's just, I think thank you for the great presentation here. So the importance of synthetic data is also in any type of privacy preserving computing is around this concept of privacy budgets that we mentioned earlier today. So if you just want to test a model on a given private real data set, then you have a limited budget. But for the actual model building process, you need a lot of iterations. You need to iterate, you more or less need some data that you could where you have a much bigger budget, or say unlimited budget. So synthetic data can be, the use of synthetic data there can be extremely valuable, I think. So that's.
Thank you very much, Dietmar. Yes, completely agree. So it's really about the explorability of the data, that legacy anonymization techniques in the past, it was always like, okay, we need column 3, column 17, column 32, and whatever to make one specific use case happen, which of course requires you to know in advance what exactly you will need. And this is definitely not how machine learning works. You want to have the access to all the 200, 300 columns available. And this is something that you can unlock with synthetic data and really have data that's explorable and understandable by everybody looking at the data.
Yes, maybe a question also, which leads exactly to that. So how would you address data shift or model shift to that? Is this, have you any recommendation how to approach it over time?
You're asking for model shift when a model is developed based on synthetic data?
Yes.
Basically the same as when a model is not trained on synthetic data, to update or basically correct the model every whatever you see, deem a relevant time frame, and resynthesizing data sets. So of course, factors can change, and if you trained your model 2 years ago and don't ever update it in between, then of course you will have some issues. So definitely collecting new data, synthesizing this again, and trying to mitigate this problem.
Okay, thanks.
Synthetic data engine becomes the part of your machine learning workflow, you know, as additional step within your data pipeline. That is basically you're automating the entire process end to end and recalculating when it's needed to update your model. No?
Absolutely. And then one other quite interesting aspect of synthetic data, didn't get to it in detail yet due to time reasons, but especially when it comes to fraud detection, we all know that it's a challenge for machine learning if there are not enough examples. And one of the benefits of synthetic data is that it can also be changed. And for example, you can boost or rebalance data sets and make more fraud cases in your example, which then help downstream models that train on this data to better pick up on certain patterns. So this is also one of the use cases that is quite interesting for our financial services clients.
I work for Intel, which I guess most people know what Intel does, but I'm part of our security group here at Intel, what we call confidential computing. Everybody will probably have heard about confidential computing at this stage. It's a new paradigm and a new way of using hardware-based security technologies to drive some of the things that the previous speakers have talked about. I need to start at sort of our security view of the world. My talk will be a little different than the others. I'm really going to get down into infrastructure a little bit and build it up into what people are actually doing with this. But in order to sort of give you guys a view of what we're doing, I need to just take it back down to what our strategy is. You know, security is important. I don't think I need to tell anybody on this webinar that security is important, but what's driving the need? We're in a unique position in the world where we're seeing data centers built with Intel technologies. We're seeing what people are actually doing in the data centers. We're seeing the amazing amount of data that's happening. The world is becoming more connected. We're seeing this exponential data growth. And in order to process the data, new computing opportunities such as cloud and edge and analytics are emerging, transforming business operations. There's a move to the cloud, as everybody else sees here as well, of bringing some very sensitive data sets to the cloud. These transformations that I'm showing here are driving big complexities for IT that are really increasing risks to business if the security part of this isn't addressed. So security goes hand in hand with this overall transformation. And the trends that we're specifically looking at here in this landscape that we're sort of relentless in our pursuit of is, first of all, encrypt everything. We want to see that everything gets encrypted and provide opportunities to do that. Keep workloads and data isolated from each other. I think that's paramount. And we want to build a chain of trust that's rooted in silicon. And obviously our expertise is rooted down in silicon. The biggest thing that our strategic customers tell us is that regulation and compliance with regulation is a massive problem for them. Compliance with policies and regulations generally, and I think the previous speakers have alluded to HIPAA and GDPR and now Schrems 2 and all the other things that are going on in that space. So security is only as good as the layer below it. You can have the most secure applications in the world, but if the operating system is compromised, it can spoof that application into thinking everything is okay. And as the security in the software layers improves, attackers are generally looking to move down the stack to look for new vulnerabilities. And that's why we start with security at the lowest layer possible, right down at the silicon. Once the silicon is secure, then you can start to build solutions on top of that trusted foundation. Now, at Intel, we're focused on protecting data throughout all of its phases. Dimitar referred to the 3 phases that I'm showing here as well: at rest, in flight, and in use. And we're helping to protect that platform by establishing a chain of trust that's more resilient against compromise. And the other thing we're doing is accelerating crypto functions to ensure that you don't have to sacrifice performance to implement security. A lot of the feedback we get from our clients is that security is a necessity, performance is as important, and the two are not necessarily the same thing. They want it cheap, but they also want it secure, which is hard. Now, I want to drill in today into one of these in particular, which is the concept of data in use. So we've all long understood that data should be encrypted when it's being stored, and we've known that you should encrypt it as you're moving it across the network. But what about when it's been actively processed in memory, especially today when systems are typically shared or even operated by a third party? And in that case, a cloud, so doing operations on someone else's machine. So protecting and creating confidentiality for data in use is this new frontier that we call confidential computing here at Intel. Application data and even the code itself is under attack. So gone are the days when we can rely on sort of perimeter defenses alone to keep us safe. Attackers can be hackers or unauthorized third parties or even malicious insiders. And they can leverage exploits in other applications or privilege escalations or hypervisor layers. Sorry, I've got some technical issues here. Oops. Sorry, can you guys still hear me there? Okay. Seems to have lost my network. Okay. Can you guys hear me, Amir?
Yes.
Okay, sorry. Yeah, apologies, I lost my network connection there for a second. So we need this multi-layered defense and depth strategy to make it cost prohibitive to execute this successful attacks. Now, in a few words, a trusted execution environment is effectively an isolated processing environment that runs parallel to the operating system. This provides several security features, such as the isolated execution of a program application, its integrity, and also confidentiality. The data and applications stored in these trusted execution environments are protected cryptographically, and the interactions either between applications or with the user are securely performed. That is, it not only protects data, but also the communications with remote entities, and also enables trusted device identity and authentication. Intel Software Guard extensions, also known as Intel SGX, mostly in the market, has become the sort of preferred trusted execution environment for developers. It was nice to see Dimitar refer to it at the start of his presentation. So developers who want additional hardware-assisted security for the application layer. So by definition, Intel SGX is a set of instructions that increases the security of application code and data, giving them more protection from disclosure or modification. So developers can partition sensitive information into enclaves, which are areas of execution in memory with more security protection. Developers are able to partition their application to 2 parts, trusted and untrusted. And the trusted part is what will be executed within the enclave or the secure hardware or whatever words you want to use. The enclave is decrypted on the CPU and only for code and data running within itself. In this way, the content of an enclave cannot be read except in its encrypted form by any external processes, not even the operating system or malicious insiders or whoever may be operating that operating system. Attestation is also a key feature of Intel SGX, and it can force the enclave to prove its identity, prove that it hasn't been tampered with, that it is running on a genuine platform with Intel SGX enabled, and that it's running at the latest security level, also we refer to as the trusted computing base level, which is super important if you're going to expose confidential data within those enclaves. Attestation can also be extended to confirm that a particular code hash is only permitted to execute within the enclave or to open an enclave indeed. Attestation delivers integrity to not only the platform that is being used, but also to who and what can access your data sets. As Dimitar and others referred to, the combination of other technologies using hardware-based enclaves and getting that attestation to prove integrity of computation is one area of real overlap. Now, there are other trusted execution environments out there. They come in sort of 3 formats. We've got one that's more total memory encryption, where you have quite a large attack surface in those. You got the guest OS and the VMM inside of the attack surface. You've got others that are bringing VM isolation. You'll see that from Intel and AMD and lots of others, where the guest OS and all of its contents are inside of the attack surface. But only trusted execution environments really bring the application right down to, bring the security right down to the application or even sub-application level, down to even function. And you'll see them mostly from Intel and ARM with TrustZone as well. Intel SGX itself is really the most researched, updated, battle-tested, hardware-based trusted execution environment for the data center that's out there. There's a lot of research that goes into Intel SGX. We work with a lot of academia, etc. We have bug bounties and lots of research going into what's going on with SGX. It delivers the smallest potential attack surface of any trusted execution environment available for the data center right now. It's available for the last 6-7 years, mostly on the client side of our house. And recently we've graduated it into the data center with Intel's 3rd generations Intel Xeon scalable processors that we call Ice Lake that released last year. We've brought them into the data center with enclaves that are available up to 1 terabyte in size. And that really opens up a huge area for interest for lots of different companies doing processing of video or genomics or other areas like that. Now, as we move sort of hardware-based confidential computing forward, we founded along with a lot of others that you can see here, the Confidential Computing Consortium in August of 2019. The focus for this consortium is securing data while in use using hardware-based controls. Here at Intel, we spend a lot of time with open source. We do think open source is quite critical, and that's why we helped to found and fund this original Confidential Computing Consortium. We want to accelerate the awareness and adoption of confidential computing as an infrastructure layer for privacy enhancing technology to be built on Intel SGX or other like-minded environments, or to support and reinforce others that are out there as well. It's very much a growing membership, lots of interesting companies coming here, both startups and established companies that you can see on this list. And it's something that we intend to invest in over the next couple of years. As we sort of looked at, when we built out our strategy around data center and Intel SGX and why we would bring these large enclaves into the data center, we talked to a lot of our customers, financial services and healthcare companies, mostly. Hartmut mentioned healthcare a lot in his presentation. We're working with a lot of healthcare companies on research at the moment as well. And our research really came down to a couple of areas. One is, I'm terrified to share my data, but I want to share my data without going through lots of other different processes to do it. So in this case, you could imagine that you're a data analyst in a bank who you're sitting on the submit button for to share some sensitive data. And when you click that button, some of your customers' most sensitive financial records are going to be uploaded to a research firm, which is performing an analysis on that data. You have the customer's consent, etc., but they desperately want to help anti-money laundering, for example, but you're still worried. What happens if a rogue employee at the intermediary firm stole the data, or what happens if the research firm is using your computer's data in a way that they didn't agree to? That was the feedback that we're getting from a lot of our customers. It's not just financial services organizations. As I said, it's all industries face this dilemma every time. The mobility sector, for example, is another area that has big problems with sensitive data. The brutal reality is, in a lot of these cases, is that when you send data to somebody else, you've given over technological control of that. You're reliant on privacy policies or goodwill or contracts or law, stuff that nobody kind of really reads. Ultimately, when you send data to someone else's computer, you have handed over all control. They can change the algorithms that are running, and you'd never know. They could take a copy of your data and use it for your own purpose, and you'd never know. Or they could give you false results, even worse, and you would never know. as we look at building out confidential computing with things like attestation techniques built into the hardware, we feel we're providing a solution here. Confidential computing and hardware-based trusted execution environments allows you to imagine sort of a new weapon in the privacy arsenal, the ability to protect your data even whilst it's in the hands of somebody else. So in the case of the bank analyst, what if he could examine the algorithms that the research firm are going to use before they upload their data? If he can examine those algorithms, then he can be sure that only that algorithm can access that data inside of that trusted enclave, because that algorithm will have to attest itself. So I think confidential computing gives you that sort of view that you know for sure what will happen to your information after you click that upload button and who you give it to. Many of the world's biggest pharmaceuticals and medical research companies are looking at confidential computing techniques to build a sort of new data approach for real-time insights. Both Hartmut and Dimitar talked about federated learning, which I'll show a little bit later as well. But now we're starting to see institutions offering services based on processing sensitive data using Intel SGX. So the three areas that we're focused on with confidential computing and SGX as we move forward and even into other technologies is assuring privacy of data, or giving our data owners methods to assure privacy of data, to build confidentiality solutions that cloud platforms can deploy. And you can see some of those clouds there, for example, who are offering confidential computing, and integrity for machine learning, which really comes through attestation techniques and the ability to attest to who's doing what and attest that the integrity of the computing environment that's working on those data sets. Now, as we look at where we're working with confidential computing, finance is really leading the way. And I think the reason there is that there's more money for research. There are more pressing problems. I think everybody's mentioned some of these areas already: anti-money laundering, data analytics, a lot of up and coming work with blockchains, for example, cryptocurrencies, DeFi as well, and the healthcare space. We've built large electronic health records, for example, in Germany around EPA, e-prescription, all built on trusted execution environments. A lot of research with genomics happening inside of enclaves as well, and industrial areas around data sharing. Gaia X was mentioned, and sovereign cloud, etc. In that sense as well. The mobility sector is very interested in using hardware-based attestation techniques and trusted execution environments to monetize or release data in maybe even things like Catena X. And lots of other emerging areas. But as we boil down some of the key points that were our key workloads that we're looking at, we really started this journey as a secure cloud infrastructure play, right? To protect the confidentiality and integrity of customer data in use in the multi-tenant public clouds. You'll see Microsoft, Google, and others, as I mentioned in our previous slide, offering these confidential services. And really that's allowing companies to start avail more of cloud economics with sensitive data sets and to put their data to work inside of the cloud. We're seeing a lot of interest in federated learning, as others have said before, privacy preserving machine learning for collaboration between independent data owners on model training, people or companies who may not have implicit trust with each other, who don't want to go through contracting processes, for example, to share data. A lot of work with blockchain on permission blockchain, which Hartmut also mentioned, and the ability to authorize network participants by attesting to oracles of blockchains as well. So a lot of interesting work with trusted execution environments in a transparent supply chain, for example. And trusted multi-party computation, which people are starting to do in the cloud. And I meant to say secure key management there down the bottom right, rather than secure cloud infrastructure. But the concept and the ability to provide a unified HSM and key management capability using SGX on a distributed architecture base. Now, working with trusted execution environments isn't straightforward. This is cryptography. There's a lot of companies that are using our technologies to build solutions, as I call them, our product. Intel doesn't do this. We are, as I said, we're at the top of this. we're enabling an infrastructure for a new wave of privacy enhancing technologies to come to play, and to reinforce some of the ones that are out there. You can see some of these companies, for example, that are playing on this side of the world, and they're building on top of libraries and tools that are available, you know, out in the market to build solutions here. At the end of the day, SGX has an SDK. The original Intel SGX SDK is there, and that's how people, you know, build the most secure platforms with SGX. There are a lot of other things, like you see Graphene and Oclum there, for example, where people can simply secure containers with SGX, which becomes an interesting proposition for legacy code if people want to move that to the cloud. Now, I'll talk a little bit about use cases. I can't go into the depth of others because I'm not an expert in the financial services area, but I'll do my best on what's happening with some of the other things that we see out there. There's a interest in consortium, you know, to bring data together in a centralized manner. This is one project that's happening in Europe across 14 different banks, and the challenge really is around maintaining data quality. So this consortium is bringing together these banks and data to do some critical referencing data required for trade processing and risk management and all the other regulatory reporting that goes on inside of financial services. And this is being built on a cloud, a French-based cloud, public cloud, where banks are sending data independently to a confidential computing-enabled service provider, which is an ISV in this case, and they're using TensorFlow to securely and confidentially drive data quality benchmarks for financial institutions. And this is progressing quite well. You know, the banks are receiving the output of aggregated data sets, and they're able to anonymously compare reference data attributes across banks, etc. The analytics are also shared with each banks. And what they're looking at from a success criteria here is the ability to measure the quality of client data against peers without revealing any sensitive data sets, obviously, and the avoidance of costly third-party intermediaries that are doing centralized checking for this particular consortium at the moment. So there's a reduction on internal maintenance costs, also on maintaining that data set, and the learning and training can happen as and when's needed on a regular basis. And the first use case in production here is focused on LEI with 6 of the banks in this consortium. All EU-based banks funded in this case by Societe Generale, and they've seen already 15% increases in data quality, and they hope to move this into a bigger consortium the early part of next year. We see a lot of interest in fraudulent claims as well. And I've marked some of the partners that we're working with here on the bottom of these slides. In insurance, I think insurance are investing pretty heavily in fraud prevention mechanisms, leveraging newest technologies. In this case, this is a fraud detection platform built on Azure, Microsoft Azure with Intel SGX, where this company, ClaimShare by IntellectEU, is separating claims in a public and private data and uses sort of fuzzy matching algorithms to identify suspicious claims that are suspected of being fraudulent or double dipping in this case. Once the fuzzy matching sort of happens, they're then taking the data off the chain and doing the computation between the two to figure out whether that duplicate claim is in fact coming from the same vehicle that happened in the same spot, etc., etc. So it's matching that private data off chain using SGX, and this has been launched across a couple of big insurance companies here in Europe, and picked up by consortiums like B3I, for example, the big blockchain insurance consortium. In Israel, again, looking at sort of capital markets, and there's currently no central securities lending platform in the Israeli market, for example. So securities lending is at present executed in the capital market, primarily using interbanking mechanisms within and if necessarily outside the banking group limits. So in this case, the use of DLT as the basis of this sort of new trading platform is harnessing some of blockchain's primary advantages and features, such as direct peer-to-peer transactions, smart contracts, enhanced security through immutability, etc. And this is also then using SGX to encrypt transaction data as it goes across the chain. So it's keeping private data or data private amongst the transaction participants and provides closed DLT platform members with additional confidentiality capabilities. And this has been rolled out very successfully across Israel. I'll skip a couple of these because I know I'm tight on time. I wanted to just dip into federated learning a little bit as well, as same as everybody else did. So I thought I'd throw in my my piece on federated learning as well. You know, a lot of our work is with the cloud providers, but we're also seeing a lot more federated learning requests and desire for federated learning to happen for many reasons. Privacy or data constantly changing, data set limits happening, and people don't want to double their threat surface by moving some data to the cloud. And we're seeing a lot of this in Europe and also in the US, and not just in financial services, but healthcare and also the mobility sector as well. Many different disparate data sets in the bank, but ultimately, as we look at federated machine learning, you know, we see, and I think others agree, that it doesn't protect the model generally, and it doesn't really protect the training. It doesn't protect the data completely either in that sense. So we're working a lot with, in this case, I'm showing Conciliant here, a company that's working across a lot of the big banks in the US, building a pilot for a centralized federated learning, centralized learning network that's building federated models out to allow banks to get involved in this type of federation. And in this federated case, you know, the centralized model is being developed so we can initially use synthetic data or sample of data to create the initial model, and then get into a sort of round robin situation where algorithms go to bank A and bank B and bank C. There's no direct access to the data. The models are protected by Intel SGX. In this case, the biggest fear from a Conciliant perspective was the model being stolen or somehow manipulated. The data is not exposed, so the data owners are happy, and only weights and hyperparameters are passed back to the centralized network. So the trusted execution environment here is really doing all of the protection. But not only that, it's providing two things. One is confidentiality. The second is integrity and attestation. So the confidentiality part of this helps to protect model IP and is designed to prevent attack computation. So data is not moved, promoting privacy and legislatures of wherever those local laws are. But most importantly, integrity and attestation is confirmed that only approved models and training procedures can happen within the federation, and all participants know that the rules are enforced, and algorithmic defenses help prevent bypass to solve some of the poisoning, etc., that Dimitar mentioned earlier on. And we've actually done this ourselves in the medical care area, where we've built federated models to do brain tumor segmentation across 26 different medical institutions across 11 different countries, and proved with similar to some of the stuff that Hartmut showed, that it's as effective doing this in a federated way as centralizing models. And as data starts to grow bigger and bigger and more is generated, the federated approach to, especially to large data sets, is likely the one that works out in the end. You know, a lot of people say, hey, you know, trusted execution environments are difficult to work with. Well, they're not easy, right? On the left-hand side, if you want to build trusted execution environments, well, you've got to know a little bit about cryptography and what you want to do. But by utilizing the trusted portion of applications and building down at an application or even function level, you really are garnering the most control. There's also the fastest path to using trusted execution environments, where you can take you know, runtime encryption environments or libOSs or items like that, and you can take legacy code and run them inside of secure containers, for example, which people are doing with things like TensorFlow and stuff like that. So that's where legacy code can be ported to the cloud or brought to the cloud using trusted execution environments, where Docker containers or Kubernetes containers can simply be lifted and shifted. That's why we gave it that name, to the cloud as well. And we see this in the federated model as well, as we push secure containers out into federated nodes. acceleration is very important for us. We're doing a lot of work and research into making stuff faster. You can see some figures there. Our homomorphic encryption team are working hard to address some of the scaling problems that are out there with homomorphic encryption. So, you know, we see HE as something that's going to be very important for us in years to come. So attacking that scaling issue with homomorphic encryption is something that we are pushing hard to do as well over time. We realize that performance is as important sometimes as security from a business perspective. Again, that's feedback from our direct clients out there. I think I'll finish there, Amir, if that's okay. It's a topic we could talk about for quite a long time.
To quickly introduce or reintroduce the panelists. So we have Alexandra Ebert, Chief Trust Officer of Mostly AI with us. We have Paul O'Neill, working at Intel, Hartmut Schultze, Hewlett Packard, and Dimitar Jetchev, who is the CTO of Inpher and professor at EPFL in Lausanne in Switzerland. And the interesting thing about this panel is that we are having experts from different technologies: software-based, hardware-based, secure computation, anonymization, interesting approaches. So I'm really looking forward to this panel. My first question to all of you panelists is basically something that I just received as a comment from one of my friends who is following here, and what he says as a as an expert in digital banking is rather a technical event for Mobey Forum. So it's the impression from non-privacy experts in a bank is that that emerging privacy enhancing technologies are very complicated. There are many of them, and all of them kind of seems to emerge in the same time. It's very difficult for a non-privacy expert to keep up, although there is a high need to have a privacy by design applications within the organization. So what are your favorite tricks or analogies that you use to explain to non-experts your favorite privacy enhancing technology? Maybe starting with Alexandra.
I would say my new favorite one is the one we just heard today with creating the necklace in the box. But for synthetic data, I mean, if it's very high level, then some of the analogies that have been used in the past were like, imagine it's a super rich cake, but without the calories. So you basically have the data, but without all the privacy pitfalls attached to it. And then, of course, the image example that I also included in my presentation usually helps quite good if you're talking to a not that technical audience, because you can easier assess that an image looks realistic as opposed to looking at millions of tables of your customers and millions of rows in the table and see whether they are as representative and realistic as the original customer base. I think you're still muted, Amir, so unless I should pick the next person to answer.
No, thank you for reminding me. So absolutely, yeah, we could see in your presentation, and you were not the only one using the analogies. Dimitar was also coming up with this box of gold. So interesting take on that. Hartmut, what's your take on that? Federated learning.
Yeah, federated learning. Well, a lot of people have just the notion of, well, I need to to share my data unless I can analyze it and learn on it, and that is basically not necessarily true. And there's this notion of well, let's start with the problem. What is the problem I would like to analyze, and then really think through a data flow, more or less. So say, okay, where's the data? Where do I have to analyze it? Is it something really I need to bring together? Can I bring it together? How do I have to split it? Who are the parties? And then really to go on, well, sometimes maybe it's not even necessary to get the right information out of such data for having PII data as it is regulated, like using synthetic data, for example, then have a subset first, do a, as you said before, a filtering on data for preparation, and then to say, okay, when I did the preparation, then I can learn the patterns, and then I do the life cycle. And let's be clear, to have a combination of all these different notions, because we do need encryption at certain points. We do need federation in certain points. We do need have some obfuscation or synthetic data, and we do definitely need to have the trusted execution environments. But the combination is always as good as the problem if I can describe it well. And a notion what I see a lot is that people strive for going for the overall. I want to have all the data, and I would say, well, less data is better. Think about the problem, think about what you try to reach, and then segment it in the right way. And well, we have the tools, I would say. It's possible to do so, and we can share and can work together without really sharing. And that's how I would approach it.
Sometimes people are even benefiting already from that technologies without knowing that. For example, in the case of federated learning, I think the Android autocomplete for the keyboard is actually also based on federated learning. So
yes,
those you're already exposed to this technology, you just don't know that.
I have a question then on this. My question would be, as Amir just mentioned, I mean, today we saw you presented a lot of new technology, and you're probably pioneering in each of those. But he just said something that came into my mind, like you know, a use case which probably each of us are using every day, and no one of us know that has been built with some of the technology you are presenting today. So my question would be, can you guys give some example, not on some research project, but something that lots of people are currently using, and actually there is one or the other of the technology you talked today, but we don't know about it.
So maybe we saw Dimitar nodding. Maybe you want to take that, because we already saw your box with gold. So you already kind of answered the other question. Maybe you want to take this one.
Yeah, exactly. So getting to this one, what could be better than showcase for the multi-party computation than the simple millionaire problem? So you have your salary, I have my salary. How do we decide which salary is bigger without actually revealing the salary? So revealing only one bit of information. That's, for me at least, in the context of multi-party computation, that's one of the simplest visuals or like problems that you could show to everybody. So that being said, I would go to, obviously visuals are important. What we saw in a lot of the presentations today, I think that that helps explain to non-privacy experts the concepts. I should say that also presenting really basic use cases. So one basic use case that goes in all of these machine learning models is machine learning data pipelines in privacy preserving is actually the very first step, which is the data integration. So how do you actually integrate two data sets, two private data sets, without revealing information? So that's the privacy preserving data integration, inner joins of tables and databases. So there are obviously a lot of non-trivial cryptographic technologies underneath, but you could just show the problem. You could show like an Excel spreadsheet on one side where you don't see the numbers, and another Excel spreadsheet where you don't see the numbers, and you show how you could integrate them. That's your first step before you go down the machine learning pipeline. Also, intuitive APIs. That's very important. So when we build demos or products, it's really important that data scientists are not changing their flows. They can see how these technologies can be used within their existing flows. So graphical APIs or programming tools there, these are going to explain a lot the use of how these technologies can be integrated.
Yeah, I think let's make one point here. You know, I get to speak to a lot of large enterprises pretty much every day, and you know, you can go along to a big bank, and in that big bank, you've got a team of people who are supporting secure multi-party computation. You've got a team of people who are supporting trusted execution environments. You've got a team of people who are supporting HE. And they don't talk, right? And they don't come together, and they're making it super complicated for that bank to make a decision on that. I think it's incredibly important to break those barriers down and show how these technologies work well together. You know, homomorphic encryption and trusted execution environments, potential match made in heaven, right? So, you know, securing computation and securing integrity of computation, right? So those two things. So that to me is one of the mission statements that we are on at Intel, is to show that, you know, we're not entering the pet space. We're building this environment so privacy enhancing technologies can thrive in both a centralized cloud perspective and a federated model as well. To me, that's super important.
And maybe to add to that, I think it's important that we have all the modules, I would say, and there's no one size fits all solution. It's always the issue, the problem the customer tries to solve, and then really to go to the minimum part and to extend over time. And I'm pretty sure that we have the technology already in hand, not in the right combination though, in the beginning, and it's not a one size fits all. That's for sure. But we can build this together because the modules by itself are getting better and better and working better together. As Paul was mentioning, going open source, going in consortia, going on how do we actually build this together is the only way to make it happen, to build up the ecosystems for what Dimitar was beautifully showing in getting the AUC to one is the ecosystem. I mean, we need to do that. Building modules, take the different things, and at last talk to the people. So I find this extremely important what you at Mobey do, to bring those people together and think about what is from maybe different domains, what is the solution approaches, what is the real problem. For example, histological data. There's no private information in histological data if you split off the metadata. And it's agreed that you can analyze this on computer vision. So you circumvent it like you do it with synthetic data. The principles, though, is the same. We approach the problems and say, okay, how can we circumvent good regulations sometimes, because none of us obviously wants to know a complete tracking of all our PII data. But of course, talking to other domains as well is helping a lot, and therefore we need to work together.
Yeah, what you mentioned regarding Mobey forum, Hartmut, it's interesting to follow, you know, the history. We were dealing, for example, you know, we're looking at building mobile wallet ecosystems 10 years ago. And that was also that brought in different stakeholders coming up from different angles with different technologies. We had to identify different control points to build a mobile wallet solution. Interestingly, that was 10 years ago, we identified data as one of the control points. What we didn't know at that time is that even this control point has further control points behind, and the privacy is probably one of them that we didn't pay attention in 2013 when we were publishing these kind of papers. So this is a learning curve. This is a journey where I think we all can benefit from this kind of exchange. What I'm wondering is, when you're coming from the technology side, and you're approaching non-experts who are maybe subject matter experts in banking, in retail banking, how are you able to track their pain points, the business value to your specific technology? Because obviously there are different alternatives. You can go with this or that technology. You can how do you approach that? Let's start with Paul this time.
Yeah, I think the challenge for us was a little easier than the others, right? And maybe it's the same for Hartmut. Our customers wanted us to help them move to the cloud, right? So they just said, hey, we can't continue to do some of this stuff in data center. We've got to move it to the cloud, and that was the problem that we had to solve for them. Now, by using trusted execution environments and bringing that confidentiality, integrity, and privacy into the cloud, the three things I mentioned there earlier on, SGX and our trusted execution environment is effectively a developer toolkit. I was open about that. So the only way that we could help our customer base was to sort of grow this ecosystem around us. So with our capital arm, etc., starting to invest in companies to try and float all boats around, bringing privacy enhancing technologies to the cloud. But we've always seen this as a cloud play, and it's only sort of more recently that we're starting to dip our toes into more of the federated learning work, which we've done a lot with the HP also as well. But for us, that's how we sort of moved it in, and that's how we brought our customers, let's get to the cloud and get you guys playing with cloud economic models with sensitive data sets.
Thanks, Paul. How about you, Dimitar? How are you facing this challenge?
Yeah, that's a great question, actually. So here I'm going to talk about two different aspects to it, or two different scenarios. So the first scenario is, we all talked about model improvements. So we say we can improve accuracy by 20% for credit scoring. So that doesn't mean anything to a business owner on a customer side, unless you have a solid return on investment model that could convert this into actual money that you're saving. So for example, in this particular case, the picture would be incomplete if we don't have the credit risk model and saying, okay, if we improve the detection of bad default credits by 20%, then that is going to translate into X amount of dollars less for the bank. And then a business development person who doesn't need to even know anything about machine learning could see the actual value. So the other scenario that I wanted to talk was use cases that actually did not exist before, that were not possible before without this technology. So this technology is obviously an enabler for new use cases, not just machine learning model improvements, but you're not even able to run the model due to GDPR if you don't have it. So that's the example, for instance, with cross-jurisdictional compliance. So in those cases, the business value is more clear. They're just forced to, so the customer needs to have a solution that enables this use case. So this is typically our approach in these two scenarios. There are other scenarios, obviously.
But coming back to the second approach, isn't it challenging? Because it's a two-step approach. First, you have to sell them, a use case for itself, something that they believe is not possible. So you're basically, entering the role of, retail banking practitioner, and are convincing them that they should start using AI, machine learning for something that they believe is not possible to do, without mentioning actually, your technology is coming in the second step.
So that was true in the very early days of the market. I agree with you, Amir. So that was what we were seeing in the early days. But as the market matures, the banks are starting to actually realize the use cases by themselves, which is really a good indicator of the maturity of the market. Exactly, where we want to be. And then they said, okay, we cannot support these keys because we don't have privacy preserving technology or privacy preserving solution for the computing. So are you able to provide us this solution? And it's then when we step in. So this is the much more clear indicator that the market is really maturing.
What about you, Hartmut? Are you sharing this opinion? What's your take on the business? How to get prove the business value?
Yeah, that comes a bit from my history. I come out from the account management and do business development. So actually, I was listening to the customers all day long. So what is your problem? How do we actually solve this? And what is the technology to be deployed? And the interesting thing is, and that's what I typically always do, is listen. Just listen. Listen first, not thinking about a solution. Move off the solution, how we say it all the time. Move off the solution, listen, and then prepare and say, okay, what is the different components and what do we actually try to solve? And as you just mentioned, the innovation dilemma of crossing any chasm we have here on, well, how do we deploy it? Yeah, we need to educate the people. We need to make proof points. Of course, we need to make proof point that something is possible, something is happening, and then these modules build out. And somehow I have the feeling, at least that's how I see it. But of course, this is a bubble in which I live as well, knowing a lot of technologies now, to build these together, and only the combination of those are really bringing it to value then. And looking at business problems, typically, as Dimitar was just mentioning, is it's at the end of the day, there needs to be either a cost savings or a revenue generation and additional services which we can provide. But then the way to get there is different, of course. It's centralized, it's decentralized, it's different parties, it's organizational, it's processes, whatever. And then to have this bunch of topics what we actually have to try to solve for, but still come to this very much and specific problem the customer has. And that is then, for example, as was mentioned by Paul, fraud detection in car accidents. And then to say, okay, which data do I need? And then it's the data pipelining. So start from listening first, and then try to figure out with the experience, with a group of people, of course, because nobody, and I'm absolutely convinced that nobody of us can solve everything by themselves. It's not possible anymore. And it's a combination of these people coming together and then think about it and find the right solution.
Yeah, it's an early market still. I don't know whether Alexandra and Dimitar agree with that, but it's an early market still. Really, we're looking at people who are doing digital transformation. Maturity is still in a sort of innovative stage. Privacy and security is proactive. They recognize that there's some problems that need to be solved, and they'll likely know how to do it. But it's still working with early adopters and visionaries, as far as I can see.
Yeah, great.
Yes, agreed.
How about you, Alexandra? Where do you start? Do you start explaining the difference between anonymous and pseudonymized data, or is it, or already are the customers so mature that they know what is the benefit of synthetic data?
That definitely depends to whom you're talking to. Some people already know, but I actually start the same way as Hartmut does, with listening, and then usually it is rather quickly that it turns out whether, for example, data sharing cross-border is one of the biggest pain points for the counterpart, whether it's AI training or in which different areas synthetic data could play in. But I can only second what Hartmut said. Listening first, I think, is the best way to go. And he also shared that on the one hand, you either want to have a cost reduction or impact on the bottom line. More and more, I also talk to people for whom it's really this overall risk minimization, because with the GDPR fines and the proposed AI Act fines, we're really reaching very sensitive amounts, and therefore risk mitigation also is something that's a concern depending on which department you're talking to.
Can I have a question?
Sure.
Yeah, I have a question. Looking at the big global company that are currently having their business model built around data, Facebook, Google, all the huge global company, which one, in your opinion, is the most advanced on the topic you just described to us today? And on which part of that business?
May I ask a question? In what respect? In respect of technology advancement, or in respect of ethical and trustworthy knowing of data?
In respect of trying to be compliant with the privacy and at the same time continue to generate value out of data, because that's what they are doing, right? They are, most of their money, especially the one dealing with advertising, they're dealing with data. And so I guess they have the same privacy issue that anyone else has, right? Or you think that they don't?
They don't act like that. I mean, Meta is the best example on that. So any monopoly which is going in that direction, which is now getting into a potentially political discussion, but nevertheless, any monopoly is not going to strive for that. So we need this regulation in a certain way on safeguarding our privacy. And the technology is there, but it needs to be applied ethically. And I'm extremely convinced about that, because we as humans, we have so much bias within us. So we must also take the right measures of getting that bias out. And that is something we have to really do. And there's only the society who can actually work on that. It's not the technology company. So I don't believe and I don't trust any monopoly or any kind of technology advancing without doing that. And let's face it, I mean, these are the big ones. And it's always a strive of getting how big is good, of being system relevant, or to be regulated and then hindered to apply and deploy technologies which might be counterproductive.
So what you are saying is that the big player, the big global data-driven company, are not working with the technology we were discussing today, mainly because they don't care about privacy, or they are in a monopoly situation where this is not the point?
That's not what I'm saying, but you just take the meta discussion we currently have, right? About how much, what is their primary North Star? Where are they leading to? Are they deploying technology for good, or are they deploying technology just for exploitation? And I mean, there's different companies who have a technology advancement and do great stuff, but still have this struggle within a large, let's take our hyperscalers, let's take in different jurisdictions. If we go to China or Americas, we have different approaches here. This is always this leveling out. And what I'm absolutely convinced is that the overall getting bias out needs to have a certain ecosystem working together. And it's not a one can take it all or must be the central custodian somewhere. That is something which we need to prevent. And there I come to the open source. I'm very much in the open source space also, or I'm a believer of the open source, that we have the right connections, have the right combination of people and organizations working together to actually get the insights out of that.
Maybe.
Sorry, Alexandra, please.
Thank you, Paul. Maybe to add to that and to Maurizio's question, I know that two of the players already mentioned working and looking into synthetic data. I'm not an expert on the other emerging technologies that were discussed today. From some conversations with members of this company, I know that they're looking in some technologies, but have diverging opinions within the organization. In general, your question, I think, is easy to answer, because from the big players, we have a few companies, they're not that dependent on exploiting customer data as the others. So for example, the business model from Apple and also from Microsoft puts them in a position where they can actually use privacy as one of their USPs and competitive advantages, versus Google, Facebook are maybe slightly differently positioned. So definitely for Microsoft with GDPR and this increasing regulatory complexity, we tremendously benefited from this landscape because it is becoming so complex that cloud providers are now in a much better position than any other small solution providers to make compliance easier for large companies. So I know they're looking into some of the emerging technologies, but up until now, I haven't seen any one of them going full steam ahead on any single one of them. Maybe to what Paul said, it's a still emerging field, and they're also evaluating and looking into them.
Yeah, I think so. I was going to make the same point about Apple and stuff, but I can guarantee you that they're looking at all of these. Absolutely guarantee you they're looking at all of these technologies. There's no doubt about that. But you're trying to turn an oil liner. You're not just going to turn that quickly. It's going to take time for this to happen. We talked about sovereign cloud earlier on. To me, we've entered the decade of sovereign cloud. This is it, right? I think it's right in front of us. And I know Google, for example, are doing incredible work on sovereign cloud in Germany, for example, for industrial cloud and stuff like that. So these companies, although they have two-sided business models, privacy is becoming a thing. Here in Ireland, we're super proud because WhatsApp got fined here a massive amount of money recently as the first fine under Schrems 2. So, some of this stuff is starting to come down quite heavy. So more of it, please.
Also, and basically extending their existing ecosystems to provide to basically provide this privacy layer as a part of their existing technology stack to their customers is probably something that will develop in the same way like it came, for example, machine learning applications where they just understood that that machine learning is just additional layer on top of their infrastructure. So they came up with their own platforms just to support that. I expect them to come up also with some privacy layer so that they can keep their customer within their ecosystem.
Yeah, from the cloud perspective, they need to be providing zero trust. Just because you're taking your data to a cloud, you shouldn't have to trust that cloud at all. You shouldn't have to trust that, they can see your data or do anything with your data. You shouldn't even have to trust that the integrity of the computing environment, that trust comes from them as well. That's the future. And if we're going to build sovereign clouds, it's got to be around those principles.
I mean, so I kind of agree with the earlier comment of Hartmut on the use of these technologies. So first of all, the big tech companies, true, they've hired the top level experts in, like they've definitely hired top level experts in these areas, no doubt about this. Do they have use cases for these technologies? Yes, they do. So the question is, what do they do about the ethical application of these technologies? And I think this is going to be increasingly important. So undoubtedly, the technology is there, and they look at all these different technologies for sure.
Absolutely agree. So especially with responsible AI, many of these big players realize now also with the proposed AI Act from the European Union that they won't be able to make lots of business if they don't have tools for responsible AI. So from the conversations I had, I learned that they're currently really thinking hard on how to actually build products and put it into all the product pipelines, because of course they have world-leading researchers in all of these fields, but they don't yet have the full suite of tools needed to actually make it happen. So I think that there we will see quite a lot in the next two years potentially.
The willingness, like the Google ethics example shows. So sometimes they're not even in line with the results of their teams, research teams. We haven't touched. I would like still to conclude this panel with a question about hybrid pets. So we were actually the good thing is that all of you touched in one way or another this idea of combining different privacy enhancing technologies together. There is, I think, there is many. If you look at the Gartner or Forrester, all of them, they also tend to agree that this is kind of the way to go. So there in the market there is kind of the common understanding that this will come. So my question to all of you is: what combination of privacy enhancing technologies, what hybrid approach do you see? The one with most potential in the short term? I know it's a bit provocative question, but and probably difficult to answer, but still, let's hear your thoughts on that. Who wants to start this time?
Well, I can start. I would always go to the use case again because it's too broad otherwise. So for example, if I do not have the necessity or I have a large data set, which I can potentially completely anonymize in the beginning, example, histology data of a tissue, no question. I would not deploy homomorphic encryption because it's an additional layer of performance, complexity, 100x, whatever. This is an impact I don't need. If I, though, have a combination of banking data with anonymized data, then of course I would combine that and do a secure multi-party, but leaving data at the edges. So it really depends on the use case, on how I would actually combine those. And I would potentially always take the TEE. So Paul, I would always take yours because that's what we need to be, and maybe even go into the supply chain on the silicon by itself, so that we can attestate that the computation which has been done in the silicon is right. Nevertheless, I would go always up and say, I need the identity, and that's the question which came before, the SSIs, which are then be given out by either a self-sovereign identity or a government which is trusted only for giving the identity. So we have the complete chain from in silicon until the end. So the architecture is fine, but then to define, really depending on the use case, which I need. And I come back to the synthetic data. I would potentially start with synthetic data for usage to get the right seed model, the ground truth somehow, and then to extend and also deploy additional things. But always it has to be in a common sense at the beginning already to have the right architecture, that all these different aspects can be used and should be used. That's my target, to define the target and then step by step do the approach and what to employ in which phase and in which size and spread and scope.
So maybe to add to that, the question of what hybrid combination is the most suitable for use case, I should say it depends on the use case. So that's the first step. So if you're doing, it's one thing. If you're doing model prediction, it's another thing if you're training a model. So these two use cases would require a completely different combination of privacy enhancing technologies. Actually, something that I saw recently, which caught my eye, was an online simple questionnaire where people are trying to classify, according to your problem or use case, what kind of technology or combination of technologies could give you, could solve your use case, just based on a simple questionnaire, simple like the COVID questionnaires that we are doing online to classify whether like the patient has COVID or not. But so all of these tools, they are going to be important. Now, to make us, like, to make this happen from a technology point of view, we obviously need like very solid and intuitive development tools. I mentioned this a few times in my talk as well. So deployment orchestration are important, but making sure that, for example, you could chain part of the computation that uses FHE with part of the computation that uses MPC or trusted execution environment within the same programming environment. That's going to be very crucial, and that's a non-trivial task. Also, making sure that you could validate your program from a security point of view, making sure that you don't exceed your privacy budget to compute on the data. And like last but not least, very important, during your model development, the use of this of the synthetic data that we mentioned. So we still have a long way to go, even if the technologies are already there, to build this entire ecosystem to allow that data workflow.
So
sorry,
still,
I'll just add quickly to that, Amir. I think we want to build an environment where all these pets can live happily, right? So we can take things like homomorphic encryption, build it into trusted execution environments to provide integrity of computation of data and all that sort of stuff, or we can take, we're already running pseudonymization engines inside of trusted execution environments in the cloud for that extra ring fence of insurance. We should do that with mostly AI as well, obviously, Alexandra, at some point. But ultimately, there's the vision should be that there's a DevOps person who has some data sets, and that DevOps person has a marking on that data set that says this is super sensitive, and they should press a button, and at the end of the day they shouldn't have to worry about which cloud it goes to or which technology takes care of that data at the end of the day. That's the vision, I think, for sort of confidential computing, embracing all types of different technologies. We're way away from that yet, but that's the journey that we need to go on over the next 5 to 6 years to enable that.
So that was actually my follow-up question. Right now, we have a feeling that this is the thing that right now we have the feeling that this is still custom-built solution. Every use case is a bit, especially when we tap into a hybrid solution, it's a kind of custom-built solution. So when do you expect to have products that, the out-of-the-shelf product that do exactly what you mentioned, Paul? Just basically understand the complexity, the privacy complexity, and then combine the different approaches together.
I think the answer could be in Dimitar's magic box at this stage. I don't think we know at this point, but there's two crucial parts to this. It's not going to get done by companies like Intel. We'll build the infrastructure to enable it to happen, the plumbing, if you will, right? It's the ecosystem that's going to drive that. The second part of that, I'm a firm believer that open source will lead the way here, right? And that, working with open source is going to be absolutely critical. If companies don't embrace open source in this area, I think they'll lag behind. This confidential computing reminds me a little bit about when VMs came out, first of all those years ago, right? It's going to be something that has to be open source driven. If not, standards will fall by the wayside. Unless we get into open source, it has to be standards and certain ways of doing things, attestation protocols, et cetera, et cetera. If we don't go there, it'll just end up with loads of different privacy enhancing technology companies competing with privacy enhancing technology companies. And for data owners, that's a nightmare.
Yeah. Maybe that's the notion, standards. That's where we need to go. If we have standards and the standards deployed on data quality and privacy, on requirements which have to be employed or are easily employed, then so each base and founding product, which is then one of the modules to be deployed in a vertical solution, is then having already this within, and that's something we have also to work on based on open source and then coming to standards. So like service descriptions in Gaia X or something like that. That also the notion of what is private data, what is the classification, how do we treat it, if classification type 2 needs to have a TEE of further standards, and that is something which has to be built out.
Yep. So standardization is definitely very important. I agree here with Hartmut, and back to what Paul said earlier today. So what we see nowadays is a lot of standardization efforts, but they're segregated by technologies. So there is a homomorphic encryption standardization effort. There is standardization effort for, say, like multi-party computation or trusted execution environment. Somehow what's missing is the intertwining of all these technologies. So we also need to work towards that.
And this, in the confidential computing sense, when I showed the the slide were all the logos. We're starting to work on standards with attestations so that other hardware providers can attest to our hardware, for example, to open that. And what that starts to do is open up a cloud to edge where some T's may be better at the edge than we are, for example. Then you're getting into integrity, you're getting into provable data, you're getting into provenance of data, et cetera, right? And that's why standards are so important. And it is doable to do this type of thing. So fingers crossed.
So Mobey Forum, actually, I hope we contributed not only with this event, but also with this panel to point in the direction that also banking industry will basically will be will welcome this kind of standardization where we can come up with the use cases and then enjoy all these kind of technologies and are being able to consume this. And I'm really happy that we were able to spend this time together in this great panel. Thank you very much for that. And who is also can talk a bit now from a banking perspective. What is your take on this on the issue of privacy? How you see it?
Well, first I have to say I really enjoyed the panel. I understand half of the things you guys are talking about, but on the other side, I also have full trust on what you're doing and it's going in the right direction. So when I asked the question before about what the big tech players are doing, it was not cynical. It was just trying to understand, okay, if they don't drive this, or if some of the big tech don't drive this, who else should drive this? Because it makes total sense, right? And I think in general, regulated entities like we are as bank are probably the most, it's an industry that needs to go into that. I mean, if you're not doing it, who else? I mean, if you're not applying privacy and properly, we are uncompliant, so we're going to have trouble. So we don't have any alternative, let's put it that way. And as actually, I believe that the future is about, also for banking, is about really trying to make the best out of the information we have. I think we need to find a way to do this in the most compliant way.
Can you share anything from your side? What are the challenges that you're facing?
Looking at, I speak for my banking group where I'm working on, and which we are located in different countries. We have operation in different countries, and we have different maturity in different countries though. The challenge for us is basically to make use of the gigantic amount of data we have in our systems. It is true that bank has tons of data. What is really true is that we have tons of unstructured data. And the way to make use of these informations is to structure them first. And unfortunately, in many cases, we store information, but we don't structure information. So we are starting ourselves to look into a new way to handle data within our group. And we believe that thinking about data away from the classical silos, some of you mentioned before that the silos are, or the fact that data engineers in different parts of an organization are using using different technology, but they don't talk to each other, they don't share experience, they don't share models, they don't discuss, they don't leverage each other's work. This is the reality in many large banking organizations today. And if we solve that, if we break those silos, probably there is a much higher chance that value comes out of those experiences. This is not true that there are no great data engineers in bank. There are. We had some very good projects. We're having very good risk model, for instance, since years, right? The point is they're very restricted within a very specific verticals. They are normally, if you look at how those projects are financed, they're normally driven by a sponsor, which is only interested in one output and is not interested to any other output. Then, if I'm sponsoring a project, I have tight money, I want to get the result I want, and I'm not interested in my team is looking left and right or sharing with someone else. We need to break this thinking and try to go towards the direction where you say there is a bit what we call in some of our exercises within an organization data as a platform. So someone who takes care about the core data we need to structure, keeping it alive, maintaining it, making sure that everyone can use it in a very simple way, making the documentation, making sure it's shared across different divisions. And yeah, that's the direction we're currently working on. It's not easy, but we think it's the only way to go. But this is only one part of the story. So what I mean is, this is solving the technological access to the data information, but it doesn't solve the complete picture. The other big problem in large banking organization is that there is completely different attitudes towards data access and data utilization. You're going to have the data platform, or the data officer, who will tell you, don't touch it. You will have the guy from business who say, well, touch as much as you can. You need to give me something out of it, right? And then you're going to have the legal guy say, well, if you touch it, it costs us millions of euros, right? And then you have the CEO say, well, give me this table. I try to calculate the risk, reputational risk, operational risk, and so on. And then I decide if you can touch it or not. And I think, and each of these people are basically looking at the same regulation and interpret those regulations in a slightly different way, because the regulation not really written beautifully in this sense, or they leave lots of space for gray zone, and so each of them has slightly different interpretation. So the other big elephant in the room that needs to be solved, beside the technological access, so the technology stack, how you're gonna make a data engineer really working on data rather than working on access to data, is to solve the understanding of, so the purpose. So every company, in my opinion, should have a clear documented purpose, which data they are collecting, why they are collecting it, for which use cases they can use it because it's their legitimate purpose, for which use case they can only use it under a specific explicit permission of the customer, and for which use cases they will never touch it no matter what, right? And so this should be structured, documented, in my opinion, should be very precisely written into, we call it a data charter, you can call it a policy, whatever, doesn't matter how you're calling it. You need to get this undersigned by the management, and the management of risk, the management of business, the management of legal and compliance, etc., etc. And once this is agreed, then you can share this around the organization and tell your teams who are dealing with data, say, guys, this is the Bible. That's what it is. That's where we can, this defines where you can go, where you cannot go, where you need to ask permission, where you don't need to ask permission, what we allow to do it, and why we're allowed to do it. That's a second pillar. Without this, even the technological solution will not help us. You will still have fight within the organization, because I'm business, I say, well, I can do this, it's pretty normal, it's my legitimate purpose as a bank. Then you go to legal and say, well, that's your opinion. Our opinion is different. So
Maurizio,
this needs to be solved.
we were discussing before, and maybe it's just the wording, we were discussing this iterative approach to that.
Oh, yeah.
Do you think that the Bible is the best expression how to name it? Because I think it's also iterative, no?
Well, it should be a living document.
Exactly.
I meant Bible from the point of view is, normally, if you're religious, if you have a problem, you open the Bible, you find a solution in there, right? So same story here. I'm a team, I want to solve an issue with data. I open the Bible, I should find the guidance how to fix it, right? But what we discussed before, you're completely right. I think that what we are missing in large bank organization are, for instance, lawyers that are IT expert too. So technical lawyers, so IT lawyers. We have lots of very good banking lawyers. We have many lawyers coming from the regulatory side of you. But what we are missing in many of the organizations, a lawyer with a deep understanding of technology. That's what we miss in banking on one side. And I mean, we try to get better there by training our existing lawyer, but also hiring specialized lawyer on that topic. And the second problem is, and this is what I'm not just mentioning here, I also mentioned in my exchange with the regulator, I think regulators should learn making better regulations. Most of the regulations that are in place today, they tend to be, because of the current situation of the business, they're very technically driven. And therefore, in my opinion, regulation are mini technical projects at the end. There is a lot of technical reference into that. And if you look at how regulations are done in Europe, for instance, in other countries different, but in Europe, the regulations are done like IT project have been in banking have been done 15 years ago. So you spend 3 years trying to get golden plate everything, try to cover all the use cases, try to think about any possible edge case, So 3 years of really hard work. And then after 3 years, you issue the paper and you think the job is done. But the job is never done. And so I think also building regulation should be an iterative project. You start small, you pull out the first version, you see how people react, you listen to them, you get feedback, you tune, you issue an extra version. But we are not there at all. If you look at PSD2, it took us 5 years to issue PSD2, and we are still at version 1. UK, they are version 5 or something, right? And they did it more iteratively. So I think there is a lot of improvement to be done also on the regulator side. Yeah, that's my view.
Thank you very much.
Thank you.
Mauri. We are close to conclude after 3 hours of very insightful presentations, panel, and kind of at the end even the opinion of the customer. We are coming to the end of this event. I would like to finish with 2 things. The first is really the thanks to experts who joined us virtually here in Helsinki during our expert group event, and really enriched with your insights our understanding of privacy enhancing technology. I hope that this kind of collaboration will continue in the future. And second, I would like also to just provide few news regarding the results and output of our group. So we already mentioned that we published the first report in June of this year. Next year, in January, end of January, we are starting with a series of small reports on each of those technologies today mentioned. So we'll publish them quite frequently. And it would be also great to involve you as experts in the finalization of these reports. And for the Q2 of next year, we are planning to publish the report on hybrid approaches. So exactly the topic of today, I think it's in our view is a very worth of dedicating entire report only to this aspect, how to combine different privacy enhancing technology into something that is of value to banks, and really which use cases can benefit from which hybrid approaches. With this, thank you very much, also all of our LinkedIn viewers, and have a great afternoon. Thank you again, and bye from Helsinki.
Thank you.
Bye-bye.
Thank you. Bye-bye.
Just on time.